Hey all, thanks for joining us today. This is an extremely intelligent panel, and I have the tremendous honor of having to moderate this. I really feel like I get to interview rock stars here. For those of you who don't know me, I'm Wen, and I work at H2O. I'm a customer-facing engineer / data scientist. And today, we get to talk to a number of Kaggle Grandmasters and Masters, including the number 1, number 3, and I think number 5 person.
Number 2.
1, 2, and, oh, I'm sorry, yeah, 1, 2, and 5. See, I already made my first mistake as a moderator. That's what happens when I have a few drinks. Before we kind of get started, let me get each of the members, maybe starting with Phan at the end, to introduce yourself, and maybe to share a little bit about how you got into Kaggle.
Yeah, hello everyone. My name is Mathias Müller. I come from Germany. I'm currently living in Dresden, born and raised in Berlin. And my name in Kaggle is Phan, and currently 5th in the world. And I started Kaggling after I finished my studies, and I wanted to get out in the world and apply what I've learned, and I pretty much failed at my first competition. It was pretty bad, and I thought, oh, I studied the wrong thing, and what is it what I don't know, actually, and that hooked me, and I wanted to get better at machine learning and predictive modeling, and yeah, that's where my journey actually started, and doing that, it changed my life, obviously, and I learned a lot of new things, and I also was happy to meet amazing people. It's a great community, and it's a really lovely place, and but for sure the best place to learn state-of-the-art machine learning.
Great, thanks.
Hello, everybody. My name is Gilberto. I'm actual number 1 on Kaggle. I'm graduating in electronics engineering in Brazil, and I've started my data scientist journey in 2012, like 5 years ago, competing in Kaggle. So Kaggle helped me to start on that data science journey, and I did pretty well on my 2 first competitions. That's why I continued learning even more from Kaggle, and that's it. That's me. I still competing, not as much as before, but I still there on number 1.
Thank you. Hi, I'm Marius Michailidis. I go with my Kaggle nickname is Casanova, which this is based on a software I had built. So I really wanted to become a data scientist, and I try to teach myself, machine learning algorithms, how to code them. I built a software at some point which included some basic statistics, and it was mainly focused for credit scoring. And I named it after my mother's last name, which is Kazani. And ANOVA, which is a statistical term, is for analysis of variance. The thing it encompasses the love I had for family and statistics. So then I wanted to see the next challenge. I felt I had upskilled myself enough, and I wanted to test how well I would do against the world's leaders. And I found Kaggle, and although it was a bit demoralizing in the beginning because everybody was like so much better, I've learned a lot, and it's very addictive. You start one competition, then one brings another. You really want to become better. You learn a lot, and this is pretty much how I started my Kaggle journey. I'm currently number 2. I used to be number 1. I will keep competing because I totally love the learning, and I want to get better. That's about me.
Okay, so hi, my name is Dmitry Larko. I live here in Bay Area. I was pretty happy data warehouse architect until my father actually showed me the Kaggle. It was like 5 years ago, and after that I desperately trying to be as better as I could on Kaggle competitions. So yeah, I'm currently, I would say, in top 100, so way much worse compared to you guys, which is actually make me more desperate. Okay. All right, so.
Hi, I'm Mark Landry. I've been at H2O for a while. I actually arrived here because of Kaggle, really. I started competing because I was going to some R meetups, and one of the people there at the time was ranked 5th, and he was doing a talk, and he said, or actually he wasn't, he interjected on somebody else's talk, and he said, people don't do random forest anymore, they do GBM. And that kind of got me looking at it, and I just looking at it, you know, people had asked me before about Kaggle because I started doing this data science-y thing. And I said, oh, can you do that? And I was like, I don't know how to do that kind of stuff. I'm just learning what I'm doing. But it's so easy to compete that I looked at it and I was like, well, this actually could be kind of interesting. So my first Kaggle commission or submission was a CSV created from a database. It had like 8 different values, but you get like halfway in there. I was like, well, that was easy. I'm sure I can do better than that. And 5 years later, here I am. So it is addictive. I did pretty well on the second one, and so it was easy to get kind of hooked into all of the gaming that goes on. But there's a lot to learn, and something I used to tell people a lot is that law of diminishing returns, it feels like with Kaggle, it waits a while to set in. Like it seems like your next competition is going to be a different data set, there's different tricks there, so you're learning something new for quite a while. You know, I'm like, yeah, I'm not as active as I once was, but it's really fun and it's really addictive. And if you open your eyes, I think there's something always to see in Kaggle. So I'm here because I reached out. Arno, in our currently CTO, was doing Kaggle, and just to kind of get H2O awareness out there. And so I saw it. I was playing with H2O for that reason, and I reached out to him to team up. And started doing that with Arno, and then I eventually moved here, although I moved back. But so it's, I'm currently, I think the best ranking was 33rd. I'm even ranked below Dmitry, so I guess we're nearly going the wrong way here. But it's really fun. It's time consuming, but it's really fun.
It's actually going the right way, because I'm pretty sure my Kaggle score is the lowest. Anyway, so we can use Slido. I got a few questions, but you know this really is a fireside chat. So if you guys are not into kind of using electronic Sasher questions, just go ahead and raise your hand. It's a small enough group now that I'm more than happy to just call on you and whatnot. So here are some of our questions, and all things being equal, maybe we'll just start with the first one. How did you decide what competition to compete in?
Well, it basically depends on the type of competition. So I personally prefer, let's say, the old school tabular data competitions with like binary classification or regression. So far I skipped a bit the image classifications because in past I didn't have the GPU power to really be competitive in that. But I think that will change in future, and I will probably focus more on that. But yeah, basically it's currently, or in past, it was the traditional tabular data competitions. Other than that, there's no much rule sets you can say in advance, because actually you have to look at the data to say if it's actually worthwhile to compete at it. But potentially every competition is interesting, so yeah.
Well, actually I joined all the competitions, of course. But actually I just dedicate my work and my time to the ones that I feel more comfortable with the data set. In my opinion, there are two kinds of competitions right now: the deep learning ones, image classification, and structured data sets ones. They are really different one from the other. And I got pretty used to compete on the structured data sets before. I got very comfortable doing that kind of competitions, but from 2 years from now, I started doing some deep learning in image classification competitions. I want to have more knowledge on that area also. So yeah, all the competitions.
I also read an article once that I think your wife gets mad at you every time you touch a computer.
Yeah.
Go ahead, Casanova.
So yeah, I basically see where Gilberto goes, and and try to compete against him. so I have to play in every competition. He doesn't give me any slack. No, I'm kidding. But it's true. I also like to try everything. But I think the urge is, I just know if a competition goes by and I don't enter, I feel, there's knowledge I might miss. I know there are always new stuff that come out, and it has happened to me. I miss 1 or 2 competitions, and then I feel it's tough to go back into, because there's progress, and that progress is very, very quick. But I'm keen to. I think my mentality with choosing competitions is similar to Mathias. Actually, I'm not very good with image classification, so it's not that I don't enter, but I don't invest that much time. I probably spend more time with tabular data. Obviously, I like a lot of stacking, so competitions will be ideal for this. Tabular data, a clear metric like for regression or binary classification will be good for me. But in principle, I try them all.
Well, I'm just trying to enter a competition. I really understand what actually is, needed to be done. That's one of the main thing, because there are some competitions that's really hard to understand what kind of metric you're trying to optimize and what kind of data set you have. So it's more like a understanding. And because I'm lazy, I never compete in a lot of competitions at once. So usually I could cherry pick 1, 2 at the max. So yeah.
Yeah, early on, it was definitely only 1 for me. And so I used to try to get a bunch of people to do it together. And so we would actually try to pick ones that we weren't as familiar with. Like people wanted to learn NLP, kind of took a vote. Okay, we'll do that one, and moved around to some black hole, weird kind of stuff. So it's kind of fun to move around at first, and then you sort of get to picking the ones that you're a little better at. The ones I prefer the most are the ones that sort of have a lot of relational kind of data in there that you have to think about feature processing, things like that. That's kind of what I'm best at. I don't get much out of the hyperparameter tuning war, but you can usually still find interesting things in a lot of that. I guess ones that look more like business data sets tend to be interesting to me, and where I can think about what's going on. And sometimes you can spot one that has like maybe small rows, and you just know everyone's going to go with a giant, Casanova-style stacked model, and that's not me, so I try to stay away from those.
Awesome. So it looks like we got 2 likes for this one. Pro tip. Any feature engineering tips you guys want to share?
Well, let me start with myself, all right? So I gave 1 webinar and 2 talks on our meetups, what kind of feature engineering to do, and what kind of tips I would like to share. So you can find them on our website. So yeah. A short sales speech from me.
And he put really good features in driverless AI as well.
Yeah, I put all of them actually there, except the most important one.
I guess, I think, yeah, the features that Dmitry has is pretty much what I use as well. I think it's valid to say that every type of competition needs its own features. Like time series, you need a different type of features. You need like lots of flags. NLP, you need like different features, TF, IDF, maybe some SVD on top of that. But I would say 2 features which I like is because I started a lot with linear models and logistic regression. I like a lot to work on binning numerical variables and creating weights of evidence is something that, which is a type of target encoding suited for binary classification. It's just I put a lot of effort in this type of features because I like them. This is the first type of feature engineering I've learned, so I do this quite often.
In my opinion, the best feature engineering depends on the data set, definitely. But one kind of feature that becomes hidden for a lot of time, just a few people use it before for feature engineering, is target encoding. I think target encoding was the key for many of my previous Kaggle victories in the past. But it's not only about target encoding. It's how you process the categorical features, right? And right now, one kind of feature engineering that is very helpful for all the models I'm testing is the categorical embedding using TensorFlow or some deep neural networks. So what I would say, try all the feature engineering you know for all the data sets, and pick only the ones that works better for your data set.
Yeah, but like to give more general tip to think about the strengths and weaknesses of several models. That's always a good starting point. So if you know, okay, how does actually a tree work? So you know, okay, it's good with numerical features. It's pretty bad with high categorical features. So target encoding comes to mind. And if you have a time series data, you know, tree-based models are not able to extrapolate. So what do you do about it? That's the kind of questions you have to ask yourself, and then you go ahead and search in Kaggle forums and read winner solutions and stuff like that, and then you get the idea about what actually helps. So you need to try a lot of things, and yeah, like Gilberto said, it's always really data set dependent, what works and what not works, but you get the right hints by asking yourself the right questions and knowing the strengths and weaknesses of every model.
I know one thing that I've learned from at least discussions with Mark and Dmitry that's not necessarily a feature engineering thing is what Mark would call a validation strategy. So thinking really hard about how you do your cross-validations, how you make your holdout samples, and what's actually getting trained on, at least is a pro tip that I picked up from these guys. I guess we'll go to the next one that's kind of ranked. What are your favorite tools to use?
I'm definitely liking driverless now, but we'll keep the pitch out of it. Although that is part of where I was in first place a few days ago. I'm data table most. I've been an R user coming from SQL, so I use it for everything. And it's just Brandon as well. So we're in it. It's interesting because it's enough of an ecosystem where we can find people that know that and use it for the projects we work on. But that's where I do almost all my feature engineering and just exploring the data set and everything like that. So data table in R, I guess, is going to be similar to your Pandas, dplyr, and things like that, just faster. So.
Well, I am mostly Python user, so it's that immediately remove data table out of the equation, which is kind of sad.
Only for a little while.
Yeah, I think I'm asking Matt to create a Python version for the last 2 years. No, year and a half, I'd say. Hi, Matt. So yeah, but in general, I would say, because I'm a Python guy, scikit-learn actually one of the most frequent tool I use, because it has a variety of machine learning algorithms and it's like a weapon of choice. If I have to do like a bigger data set, of course I have to pick up something else, but that's basically scikit-learn and my own scripts, and maybe drivers AI, but not quite sure.
And I should refine mine. As most of us will say, we all pretty much use some flavor of GBM these days, and I use GBM for almost everything, even when it may not be the best tool for the job.
I have to admit, I use a lot of tools. And I think if you want to do well in Kaggle, you have to know generally the tools. You know, there are different competition or different problems that other tool would work better than others. But in principle, I also use Python. Personally, I like Java as a language, and I started creating my own things, but over time, I think I have fully switched to Python for a lot of things at least. I mostly do pre-processing with pandas and sklearn. In terms of algorithms, I will say I really like XGBoost and LightGBM for as gradient boosting trees. For deep learning, I really like the H2O and Keras. For linear models, I like the liblinear implementation. I like libfm for factorization machines and libffm. I don't know what else. That's pretty much it. Yeah, these are the tools I use most of the time.
I have a lot of tools that I like. I started machine learning programming in MATLAB. I won my first my first competition in Kaggle using MATLAB Neural Network Toolbox. Then I started to learn R. I won a lot of competitions in Kaggle just using R. Then in R, I like very much a data table. I use it a lot, data table in R. And then I found that scikit-learn, and I start to learn Python also. And consequently, I need to learn pandas to process the tables. But I'm a fan of a lot of tools, external tools, command line tools. I use a lot of command line algorithms in the past, like Wopawebit, libfm. Well, I can list a lot of things, but that's the top ones for me.
Yeah, for me it's pretty similar. Expect R. I'm not an R user, but I use Python mostly for Kaggle competitions and all libraries which can be interfaced with Python. And yeah, for models, it's usual suspects like XGBoost, LightGBM, Keras, and scikit-learn. And if you have that in your toolset, you can get quite far. And then for some competitions, you need like maybe factorization machines, and you go to more like to command line sometimes. I don't really like it. I try to avoid it, but sometimes it's not avoidable. And yeah, but basically that's the overview. Yeah.
So I'm gonna ask the first one that was kind of starred 3 times about Casanova's crazy stacking methods.
Casanova with K, right?
I know. I didn't write that. Yes. But I think they're giving you a compliment
because this one refers to to the lover. Yeah, I think not sure about crazy, but I like to do multi-layer stacking. So imagine that you combine some models with another model, and you build so many of these models that then you need to combine these models who use models as input. Maybe it didn't make sense, but the idea is that I try to, I know that it's very difficult to get the structure right. So I tend to create many hundreds of different models, and I try to use different permutations of the data each time. For example, I'll make one data set where I would transform categorical variables with one hot encoding, and I will build an XGBoost. Then I will build another data set where I will try a completely different transformation. And I will keep doing this until I generate a very large pool of models which are semi-random. Not completely random, but semi-random. Why? Because I don't want to get stuck to some local minima. And then, once I have created this large pool, I use other models to select which of these models are useful. And because I have started with such a big pool, are required to do this on many levels, keep filtering, until I reach to a point where I can no longer improve my score. I think, I'm not sure if that makes sense. I will talk more about it tomorrow. So that's another reason for you maybe to come to my talk. But this is the basic idea. So generate a lot, because it's not easy to know before which structure or which models are best, and then filter down to what is really most useful. That is the basic idea.
And Marios and I had a conversation Friday night with a client on this, and for those of you who are not familiar with stacking, it's essentially, well, one of the fundamental assumptions is no single model or learner is perfect. They all have baked into them some assumptions and will do well on certain occasions. So what you can do is leverage all of them, and what you build is a model to decide which one of them to use. So I call it like a manager. You have all these little workers who are good at different parts of the problem, but then you kind of have a manager say, okay, I'm gonna pick this model for that region or whatnot. And he's basically built an entire, if you think of a manager analogy, hierarchy. I think you're talking about like a manager of managers, etc., right?
Yeah, manager, then you have to put a CEO. Yeah, it's just as you said, you have to build this hierarchy. Yeah.
Great, okay. This is, I guess, the next question, just by rank order, which is very similar, I think, to the other one, but, do you guys have any recommended resources to learn the art of feature engineering?
As I mentioned before, we have some links on our website, right? So basically, I did a webinar about feature engineering. I did a couple of talks on our meetups. You can also find the slides on our GitHub, right? We have a GitHub, yeah. Oh, awesome. There is a couple of very good presentation on SlideShare. You can just Google, like a feature engineering SlideShare to find them. So but there is no actually a single place which dedicated to feature engineering. All the resources are kind of spread across the internet.
I would like to add, apart from Dmitry's feature engineering presentation, which is great, I think I would like to take this opportunity to advertise our Coursera course, which we made it with other Kaggle Grandmasters, and it focuses a lot on feature engineering. Don't remember the exact name. It is something like Win Data Science Competitions, but we have capitalized a lot on feature engineering and what you need to use in order to win machine learning competitions. So I advise you to try it. A lot of code, lots of notebooks. Obviously, it is based in Python, but it should be very, very comprehensive.
Yeah, actually, the question is very good. Feature engineering, it's an art. And like every other art, the only way to master it is train. So you need to put your hands on some models. You need to try by yourself. Most of the automated machine learning models right now is trying to do that automatically. And this is something that is very hard to do automatically. That's why it's an art. So what I recommend to learn feature engineering is doing Kaggle. Put your hands in some problem, some challenge, and build a good solution. Try different features from your mind, and you see if it's good or not. And you see every data set have its own way to do feature engineering, and yeah, practice.
I can probably add some more resources. It's a talk from Titericz, it's another Kaggle and I think discussion Grandmaster, I think, and he had a really good presentation which gives really a kind of complete overview about feature engineering in general. So it's a good overview, and then I can just second that you actually have to apply it. You have to train it, and you have to think about, okay, what could be useful on that kind of data set? So maybe, okay, perform some EDA and I see something, and how can I exploit that? So, for instance, maybe a little backstory. If you compete at Kaggle, often people find something in the data set. So, and they post it in the forum, but it don't think a step further, and they don't try to exploit something. And I take such information like happily and say, okay, let's look at this. And he found it for me, he shared that, and often that leads to something, some data insight, which you can use to create some useful feature, and that makes you, it gives you an edge about those guys who are not trying to make something out of it and just claiming, okay, there's something strange, but I don't want to think about it, why it is there. So most of the times there's a reason. And yeah, so get your hands dirty and train. It's really learning by doing.
And I think maybe a bit different of a take on this would be to sort of think at a pretty bare bones level of what these algorithms are doing. So XGBoost is just decision trees at the end of the day. And decision trees have their limitations. And so you're sort of thinking of how can you overcome this? How can you represent a feature? And if you put yourself in a binary world, how can I get a question to be answered where the left goes left and the right goes the right? And that's ultimately what you're trying to do. Now, you can go overboard with that, and sometimes I've been, I'll team up with somebody who comes at me with a very generic solution. I've overthought it. But I still think that helps overall to be trying to think of, how you can extract a feature, because there's like embedding schemes or showing the features to a model. That's really one genre of feature engineering. There's feature crafting, which is sort of more of what Phan's talking there is, how can you take an insight and represent that best to the model where you're going almost deeper than normal. Like the algorithm couldn't see that before. So you're sort of trying to unearth things that the algorithm couldn't see. So part of that is what the algorithm couldn't see because of what you're doing. And there's a lot of debate. You're going to hear target encoding. You've already heard it some. That's a different encoding scheme other than one hot or different ways of doing it. And it matters. I don't know. For me, that kind of helps. I tend to think in flowcharts, decision trees. That's really all they are. But no.
Great. Okay, next question. It says, if you could go back in time to when you first started, what advice would you give yourself?
I don't really have any regrets, so I don't know. I wouldn't change much. I think I like the path that I got on. I think you have to be, we're all interested in doing it. We keep doing it. So I don't really have a good answer, a compelling answer.
Yeah, kind of agree with Mark, but I do have advice for myself, for younger me, basically, right? If you think about that carefully, that should be something like a very short advice, very practical, and very easy to implement. So I just say myself, like my younger myself, just 2 words: buy Bitcoins. It was 5 years ago, right? So it's the right time to buy it.
I don't have any regrets, to be honest. I mean, the only thing I would say is it's more like it's something that came to my mind. I would like to convey because I don't want people to feel it as well. Is you may get a bit demoralized in the beginning, because it might be a bit daunting. You may try, you may not do very well. Just, don't be demoralized. You'll get there. You put the time. You will struggle maybe the first, the second time. People are very willing to share. They're very helpful. The forums are always busy. You'll get there. Don't feel sad if you don't see yourself winning in your first competition, right? You'll get there. This is what I would say to myself. It's. Yeah.
I would say spend some time analyzing the data set and build a very good validation strategy. I mean, a cross-validation, because this is the base for a good model. Build a good validation strategy. Most of the people just fail on building that good validation strategy, and that's why they fail. So build a very good validation strategy and trust your offline metrics.
I would say to myself, don't spend so much time in model tuning. So my first competition, I spent like weeks and I just tuned models, and
No, don't say that. I mean,
No,
this is his biggest strength. I mean,
no, yeah, but
and this is why you got it. No. Pick something else.
no, really. I'm serious about it. The problem is what I see is that many newcomers spend really a lot of time in tuning the models and trying to find really the perfect set of parameters. But you can at the beginning you get something out of it, and then the time you put into it, it doesn't pay back. So and you need to find a trade-off, because there are much better ways to improve your final results. And what I observe really often, what newcomers do, and I did it as well, really spending time tuning models for the 5th digit improvement, and but sometimes you need those step changes. We call it step changes, when you really find something new, some new idea to make really a leap in your score, and model tuning won't bring you there. And nowadays I spend really little time in model tuning. It was a strength of mine in the past, because at some competitions, if it really comes down to the 5th digit and it's worth like 15 places on the leaderboard, then it might help. But in general, I don't like it to do it any longer, because it's already, I have some scripts doing it for me, but in the past I really did it manually. So I really looked like hours onto my screen and stopped and changed parameters and restarted and watched the traces and stuff. And you can do that, but you can spend your time much better, I think. Yeah.
I want to interject with a question. I've heard some advice. A lot of it's consistent with what all you have said is, get your hands dirty. What do you guys think the value of Kaggle for those that don't want to be competitive? I think there's a missing piece in the community itself, maybe the discussions in the kernels and whatnot.
Well, I would almost take it from that bottom question. I think there's a lot to learn about real-world data sets. If you keep your eyes open, I've met with people here in the Bay Area that they're just not that interested. If they can't get behind whatever's going on to win a competition, and sometimes that happens, that then they just don't. But that's fine. Take out of it what you want to. If you want to learn something, I think it's useful to get your hands dirty enough that you can see when you're wrong. I think that's the biggest thing that comes out of this. It's like homework in school, except for on a grander scale maybe, because you have these 2-month-long competitions. But a lot of times when you see the final solutions, they're not that much different from the ideas you had, but you must face the reality that you didn't have that idea. And there's something to be learned for that. And you don't have to be competing for the top 10 to see these sorts of things. You can see some of the leading models. Sometimes they're simple, sometimes they're not. But at least if you tried a little bit, you can take a lot more out of that. And I find if you're looking correctly, non-curated real-world problems, most of the problems are real-world. I've worked with a lot of companies at H2O, and you can go in there immediately, usually, and improve a model that someone's been spending some real time on, and that's because we've practiced on 50, 100 of these things. So.
Any additional thoughts on the value of Kaggle besides competitions? Of course, I'm talking to the most competitive group, probably.
Well, I think with the recent development of Kaggle, it's not just... In the past, it was all about competitions, right? But nowadays, you can contribute in many different ways, like we had discussions, all those kernels, those free data sets, and it's the best learning resource out there. It's simple put, and you don't need to be competitive to... If you want to learn something, then go to Kaggle. So if you want to compete, go to Kaggle. If you don't want to compete, still go to Kaggle. It's a simple, the best resource. And with the new features like kernels, for instance, and all those free data sets around, there's so much to explore. And even if Kaggle would have no competitions at all from now on, it would still be a place I would visit like several times a day.
I think the best thing about Kaggle, you can learn from the best competition solutions. This is the most valuable thing in Kaggle. Learn from the top players on the past competitions. You can find everything on forums. And another thing about Kaggle, you can learn from the scripts, the open scripts there, from the kernels, old kernels. And yeah, there are a lot of things about Kaggle that you can learn without competing.
Yeah, I agree. I mean, it's, I think Kaggle says is the home of data science, and the thing it lives up to its name. There are so many things you can do. Anytime I have a question, I just post it and I get an answer like fairly quickly about anything. Like, how can I do this visualization, or where can I find an implementation of this like technique. It has like news feed. If there is something new, people there, will try it. I've learned image classification, text classification, sound classification. There's just so many things you can do. It's just you might actually lose yourself trying to do everything. There has so many data sets. Like, if you want to find, so for example, I remember once I wanted to find a data set that about what crimes were in a specific area, and I was just able to find it. So it has so much. You can get value in so many different ways aside the competitions. It's even tough to list it. I think people should just have a look and see all the options that are available in order to get a better idea.
All right, so we've been very pragmatic. Maybe we'll move on to the other spectrum, and just to ping your guys' brains on how much hype do you think there is around deep learning? Question asked, recently a great approximation for word to vec was found without deep learning, and GC Forest is a faster option for representation learning.
Well, there is a lot of hype around deep learning from my point of view. So it sounds like it's a new shiny thing, and everybody, if you have a hammer in your hands, that means everything in NL. That's exactly what happens with deep learning right now. Which is not a bad thing, because anyway you would like to try a lot of things, a lot of problems to solve with a new approach. Some of these problems can be solved with deep learning, some of them not, but that's how you are learning. I'm kind of disagree about the GC Forest. To my knowledge, it was tested against on an MNIST data set. Well, it's kind of very simple data set, so basically you can do a very good job with just a random forest basically on this data set. So I wouldn't say it's a good benchmark to test anything against neural nets.
Yeah, I mean, I think like CNNs, if you're not doing CNNs, you're kind of doing it wrong on image right now. So, and you can see one of the Kaggle competitions, Michailidis, who's one of the top 10 Netflix prize winner, he named his team, I don't use CNNs, and he knows what he's doing, and he landed in about 200th place trying to make a point, and he made the wrong point. Or I don't know what he's going after, but he didn't make that point very well, I would say. Outside of that, I'm not sure. I'll let these guys talk about that, but it still seems like CNNs are definitely the way to go. I mean, we're seeing new architectures keep coming up, but.
Yeah, I mean, it's another algorithmic family you need to know if you're in this field. I mean, there has been some areas that undoubtedly deep learning is really good, like image classification. But I would say that if you want to be generally good all around, you need to know them all. I do agree that there is some hype for something that has been there for many years. It's just obviously the advent of computing power, especially GPUs, that has resurfaced, has made it, I mean, come out again. But yeah, I would still say that, you know, it is definitely something you need to learn and study, and new things will come out. But it won't be the answer to everything.
Deep learning is really interesting. Up to now, it was used a lot for image classification problems, but there are some other uses for it, for tabular data and unstructured data also. So the bad thing I think about deep learning is very hard to implement some models, and it's very highly customizable. So you need to have a very good understanding of what you're doing to work with deep learning. It's not out of the box as other models like decision tree models. So also every day there's a new papers about deep learning, new techniques, new architectures. So there's a lot of potential for the future, and we can see it's going to be very good on the future, but that's it.
Yeah, I would say there's definitely some type of hype about deep learning, and of course it produces state-of-the-art results on many domains, but it's not that magic tool you can apply to every data set and it works like out of the box. It's really hard to tune. It's much more difficult to tune deep learning models and tuning XGBoost models. That's even more an art than feature engineering, I think, to get the architecture right. And I guess even Hinton, the mastermind behind deep learning, probably is currently heading into different directions to say, okay, maybe, yeah, it was a huge step for machine learning in general, but I think he tries to, or he sees some limitations already with the current approaches in deep learning and wants to try find new ways to mimic what our brains are actually doing and how our brains work, how our brains learn. And I mean, there's still this open question how you bring knowledge from different domains into the current problem, because obviously when we learn, we use the information from past and we use different kind of informations, and the learning problem is not something you can take in a vacuum. Like if you see a picture, you already have knowledge about structures, you see there's a patterns, and currently how machine learning works is more like it's a closed system, and I think the next big step would be to break this barrier and yeah, make those transfer learning work.
All right, folks, we're officially out of time. I think they'll probably, the Grandmasters and Masters are probably going to hang out for a bit if you want to just talk to them personally. But let's formally give them a round of applause for their time and all their great knowledge.